All right, today we are learning about solving equations containing radicals. I know I've got this when I can solve radical equations by using the property of equality once and twice. So some key vocabulary: radical equations, squaring property of equality, and extraneous solutions. The squaring property of equality is if a equals b, then a squared would equal b squared. A proposed solution of the new equation that is not a solution to the original equation is an extraneous solution. So it's a solution that looks true, but when you plug it back in, it doesn't work. So here's some steps to solving radical equations containing square roots. I would write this down if I were you. The first one is to arrange terms so that one radical is by itself on one side of the equation. You must isolate the radical first before you do step 2, which is to square both sides of the equation. Then simplify both sides. Then if the equation still contains a radical, repeat steps 1 through 3. You're going to solve the equation, and then you have to check all proposed solutions in the original equation for extraneous solutions. So example 1. So the square root of 2x minus 1 equals 5. The radical is already isolated. So to get rid of the square root, you're going to square both sides of the equation. The square and the square root cancel each other out. So you just get 2x minus 1 equals 5 squared, which is 25. And then you solve. So you would get 2x equals 26, x equals 13, and then you need to check it. So you check it by plugging it back in. So 2 times 13 minus 1 equals 5. So it'd be 26 minus 1. So the square root of 25 equals 5. And yes, that is true. So once your check works, you know that you got your answer. All right, in 1b, it says radicals with an even index can never equal a negative number, including square roots, because 2 of the same number will never multiply with a negative product. So this is no solution, because a square root or a root with an even index can never ever equal a negative number. All right, 1b, the square root of x minus 1 equals 0. So we need to isolate the radical. So I'm going to add this 1 to both sides. So I get x minus 1 equals 1. Square both sides once it's isolated. You get x minus 1 equals 1 squared, which is 1. Add 1 to both sides, and you get x equals 2. Now we need to check. So I'm going to go plug that back in. So 2 minus 1 equals 0. The square root of 1 is 1, minus 1 equals 0, so that works, and x equals 2 is my solution. Okay, so here's one for you to try. And you should get x equals 24. Okay, example 2a, now we have more complicated stuff. So we're gonna isolate one side if possible. So I'm gonna subtract 2x from both sides. So I get the square root of x plus 1 equals 8 minus 2x. Now I'm gonna square both sides of the equation. So I'm gonna square both sides. So I get the square and square root cancel each other out. So just x plus 1 equals square it, multiply and double. So I get negative 32x. Now I'm going to, since I have a quadratic term, this 4x squared, I'm going to isolate one side of the radical. Move everything to one side of the equation. Okay, so I'm going to isolate this side. So this is what I'm going to do. I'm going to subtract x and subtract 1 from both sides. So when I do that, I'm going to get 0 equals, I'm going to put this in standard form. So 4x squared minus 33x plus 63. Okay, now I'm going to need to factor that. So let's see. When I factor this, I get 0 equals 4x minus 21 times x minus 3, because negative 21 times x is negative 21x, and 3 times negative 4 is negative 12x, which would give me negative 3x in the middle. Negative 33x. When I set these equal to 0, I would get x equals 21 over 4 and x equals 3. When I check those, so let's see, when I check, if I plug in 3 for x, I get 6 plus the square root of 4 equals 8. So that's 6 plus 2 equals 8, and that works. So x equals 3 is an answer. When I plug in 21 over 4, I get, this would be 21 over 2 plus 21 over 4 plus 4 over 4 because of like denominators. So I get 21 over 2 plus the square root of 25 over 4, which is 5 over 2. I would get 26 over 2, which is 13, and that does not equal 8. So 21 over 4 is not an answer. So x equals 3 is my only answer. So I'm going to pause that, and I just want you to look at it because this was a little bit of a tougher problem, especially because you had to bring in factoring and all that. So go ahead and pause it, and you can look at that for a second. Okay, 2b. We're going to do this one. So there's a radical on either side, so we're just going to square it like it is. Okay, so we would get y plus 5 equals 2 squared is 4. And then you multiply this and this and double it. So you get negative 4 square root of y minus 4. And then plus y minus 4 squared is just y minus 4. Okay, so you get y plus 5 equals 4 minus 4 square root of y minus 4 plus y minus 4. Now I'm going to combine like terms. So 4, this 4 minus this 4 cancels out. And we just get negative 4 square root of y minus 4 plus y. Now, I need to isolate that radical, remember, because we have another radical we have to isolate. So I'm going to subtract y from both sides. When I do that, those cancel. So I get 5 equals negative 4 square root of y minus 4. Now to isolate that radical, I'm going to divide both sides by negative 4. When I do, I get negative 5/4 equals the square root of y minus 4. Now, if you remember, a square root can never equal a negative number. So your answer for that one, you can stop there and say it's no solution. All right, here's some extra practice I want you to try. Pause it. And then here are the answers. Let me know if you have any questions about this. I know I've got this when I can solve radical equations by using the property of equality once and twice. Do you really understand? So what is the first step in solving the equation, the square root of x minus 7 equals 4? You would have to square both sides. Solve the equation showing each step in your solution. And you should have gotten x equals 23. What you would do is you would say x minus 7, square both sides. So you get x minus 7 equals 16. And then add 7 to both sides, and you get x equals 23.